Hi guys, Shouvik here. Welcome back to the channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have this problems partitions array such that maximum differences is k. So this problem act as a medium, but I don't feel so. It's a medium. It's indeed an easy. Just you have to identify the trick. Then it's a kind of super easy. You are given an integer array nums and an integer k. You may partition nums. So what we have to do, we can partition nums into one or more subsequences such that each elements in nums appear in exactly one of the subsequences. So the elements, so every number should appears in one of the partitions. It should not occurs on multiple partitions. That is not allowed. Return the minimum number of subsequences needed such that the differences between the maximum and the minimum values in each subsequences is at most k. Return the minimum number of subsequences needed such that the differences between the maximum and the minimum number of values in each subsequences is at most k. The k factors they have given. A subsequences, I guess you guys should know, a subsequences is a sequence that can be divided from another sequences by deleting some or no elements without changing the order. So you are not allowed to change the orders when you are building your subsequences. So on this example test case, you can see like 36125, we can partition nums into the two subsequences 3, 1 and 2, and another subsequences is 6, 5. Another subsequences is 6, 5. So what is the differences of minimum and the maximum here? The difference is 1 minus 3 is 2. It's satisfying. 6 minus 5 is 1. Absolute is 1. You want. So that is exactly they are looking for. You may partition nums into one or more such that the element in nums appears exactly one of the subsequences. It's occurring in either of any of the subsequences, and return the minimum subsequences needed such that the differences between the maximum and the minimum values in each subsequences is at most k. Yes, that also valid. On this example, this is 1, 2, 3. K is 1. One subsequences is 1, 2. Another subsequences is 3. The differences of minimum maximum is 1 here. The differences between this 3 and itself is minimum maximum is itself, that is also 3. So that delta on that case is 0. So we are still within the boundary of it's at most k. Right? We are still satisfying. On this example test case 2, 2, 4, 5. K is 0. So we can put this 2, 2 as in one partitions, then 4 and 5 we have to put them in different partitions. So how many partitions we are making? 3 partitions, 2, 2 and 4, 5, right? So that's the reason the output is 3. Yes, so I think the problem is very straightforward, and on constant it is of 10 raised to the power 5. So you definitely have to think kind of big of n log n or big of n kind of solutions to get an accepted, right? So I am just going to one note, but there is no one note needed at all. So what actually we have at to our plate? So if that is an array A, B, C, D and D, A, B, C, D and D. So now if I'm going to make it any part, so only things the subsequence keyword, right? The subsequence keyword is basically making you challenging. So subsequence is basically forcing you to maintain the order, So if you are going to make A to be one partitions, then C to be another partitions, and this E to be another partitions, then you have to follow the order. Right? So how you can, so we have already solved on yesterday a kind of solutions where how you can get inner partitions. Let's suppose you select this A, C, and E. If you select this ACE, then the delta of this minimum and the maximum. I guess it's not working again. Yes, it's still not working. It's indeed gone. So the gap between my ACE, if I'm going to consider this is in sorted format only. So the delta, the ACE, the delta is AC and E. A minus E. So that is my absolute difference. So I need it to less than equals to K for sure, for all the cases. When we are partitioning it, on that partitions, the differences between my minimum and maximum should be my less than equals to K. So then very brute, what it is coming to my brain, I will sort my nums. Shit, yaar, it's making the things too difficult. It's repeatedly going to go to this state. So if I'm going to sort it, the things, it's not working actually. I'm not know why so. It's creating problem, man. So I'm going to state you on verbally only. So because that is a kind of indeed an easy problem. So if I'm going to sort the things, can I say the numbers that I'm going to choosing, I think it's working now. The numbers, if I'm going to sort it, if I'm going to sort the things, can I write the elements? What I am doing, I'm making it sort. So then the numbers are in that format only, so all are in sorted, right? So all are in sorted. So then I will take the elements to a partition in a single. How far? That far until the starting point. If I'm going to consider it to be a mini to the current elements, the gap is still less than equals to my k, right? This gap is still less than equals to my k. So till this my partition is valid. Maybe after incorporating d, this a minus d becomes not greater than becomes k. So that means from d itself we have to start a new partitions. And what is the minimum value of this particular partitions? As this is unsorted, so d is then that starting point. Then I am considering this de. Let's suppose it also valid. Then d and e becomes the same partitions, and I am going to make the partitions from here. A, B, C is going to be a same group. The partitions from here. A, B, C and same partitions, and D and E are going to be a partitions of second. Yes. That is going to be an indeed result for this particular solutions, because I have to make the minimum partition. I make one partitions. We got two subsequences, and they are going to follow the order of less than equals to k. Only problem is the subsequence keyword, right? The subsequence is basically enforcing you to maintain what? To maintain order. Now can you guys tell me, is this altogether valid? Do we need to maintain order? If I'm going to do a partitions, right? If I'm going to partitions, so partitions mean if I'm going to sort it, so that means we are going to lose the orders for sure. So now if I'm going to consider an example test case 3, 1, 2, 5, and if I'm going to consider our k equals to at, let's suppose we have a 9 here, right? And let's suppose our k is it's still going to be valid. Then let's suppose I'm going to consider my k equals to 3, right? K equals to 3. So what I am stating, I will going to sort it for sure. So it becomes 1, 2, 3, 5, 9, and I have k equals to 3. K equals to at 3, right? I'm starting with 1. Okay, fine. You have start point of the current partitions at 1. 2 within the boundary. 2 minus 1 is with less than equals to 3. 3 minus 1 is 2. It is within the boundary. 5 minus 1 is 4. It is out of boundary. So make a partition from here. So 5 becomes a group of another starting point. So we are starting with 5. 5 minus 9 is 4. So make a partition here. So this is a part, and this is another partition, and that is the minimum partitions you can achieve. Now, are we following the now what they told? In every partitions, it should be the subsequence order. If it should be a subsequence order. So between 1, 2, 3, who comes first? 3 comes first, then comes 1, then comes 2. So we are only interested on count. We are not interested. I'm repeatedly stating why sorting works, why subsequences we don't need to consider. We are basically looking for what we have to return in answer, the count. If they are ask us to return the partitions altogether, then we have to play the games with the subsequences. Then we have to bother on ordering. So 1, 2, 3 we can't return as it is, because 3 occurs first, then occurs 1, then occurs 2. So we have to return 3, 1, 2. This something like this, right? Something like this. So why it works here? We don't have to consider the ordering, because we have to return the count. If we have to return counts, then no matter which ordering we are considering it, we are only looking to make the partition. So 1, 2, 3 is going to be in a single partitions only. So we are just making them to a single partitions, right? We are just making them to a single partitions. If let's suppose my k is becomes 1, then we can make a partitions from 1 to 2. It's valid. Let's suppose the k factor is given to us 3, 1, 2 is still within the range. Let's remove this 3 at all. Let's remove this 2 from this. So we don't have 2. So 1, 3, 5, and the k factor is given to us. The k factor is given to us is 2 only, right? K factor is given to us 1 only. Right? So now if I am going to consider it, so it becomes 1, 3 and 1, 3, 5, 9, right? 1, 3, 5, 9. And we have k equals to 1. Is it working or not? It's working now. So I have this 2 is not a picture now. I have, no, it's still not working actually. Wait for the program to respond. So I think you guys should get the gist at all. So if I'm going, so why actually this partition things, why actually the sorting works, right? You guys should get it. So this the reason, because like we are only interested to its ordering. We are only interested to its ordering. We are only interested to its count only. So that's the reason it is perfectly working. So no matter which particular orderings it is, so subsequence is basically making you confusing because there is an ordering factors, right? So if I'm going to consider this 1, 3 and 5, it's working now. So if k is 1, then I am going to make a partitions from here itself, right? I don't have the liberty to take from here, and I'm going to make a partitions here because 3, 5 is still higher. Then 5, 9 is also. So I am going to make a partitions 1, 3, right? 1, 3 I am going to make a partitions. So what is the gist you guys are getting here? If they are looking for the partitions printing all together, then we are only interested to the ordering. But here they are only interested to the count. So we can sort it and make the partitions. We have just make the grouping. We are not interested to print the groupings. You can just make the.
Hi guys, Shouvik and welcome back to the channel. So today we will solve another question from Leetcode. So let's get started.
So that should be more than sufficient. Yes, that's exactly you have to do. The code is very simple, very crisp. That is expected also. So you have very initially sorted out my mini to be nums of 0. After sorting answer to be 0, n to be len of nums, right? And I am iterating for I in range 1 to n. If my nums of I minus this particular mini, so mini is basically holding the starting point of the partitions. If it is greater than k, so that means we have to make a partitions here. So mini, so now who is the starting point of the new partitions? This nums of I. So I have stored it to my mini, and answer plus equals to 1. So that means we have just make a partitions. And after that we are returning answer plus equals to 1. So why answer plus equals to 1? Because at the very last you are going to be array index out of bounds. You are going to end it to your for loop when you have some numbers in a partitions for which they are going to be in a single group. So that's the reasons we have to return answer plus equals to 1, because we have started with 0. So let's consider your k is very high, and after sorting also everyone's becomes a part of a single partition. So you are not going to encounter this loop at all, your answer is always to be 0. So that means after your for loop executions, whatever the remainings you are carrying, you can make it to a partitions at all. So that's the reason after this entire for loop we're returning answer plus 1. Yes guys, the problem is as simple as that, I have to say. Now we can quickly discuss the time complexity. The time complexity is bound to be big O of n log n because of the sorting, plus big O of n for the iterations. That's it only. And on space perspective, the space complexity, do you guys see we are using any extra space? Sorting is in place sorting, nums dot sort is an in place sorting. So the space complexity is bound to be of big of 1 for sure, and that is bound to be the most optimized time and space complexity you can achieve for this particular video, for this particular question. And I tried my best to explain to you guys, and I think you should get the entire gist, because this is a very easy problems I have to say. And if it is so please do subscribe to the channel, and please share the videos to your friends circle who are also preparing for top product based company and brushing up their TSS skills. And please turn on the notification so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another video question. Bye guys, bye.